Dr. Nara, is it the music is stopped? The wonderful classic music.
Yeah, I thought 7 p.m. So we should start the proceedings. Or you want the music to go on for some time?
No, it was just lovely. That's all. Oh, I see Dr. Manthan in the audience for some reason. I'll just add her.
Okay, yeah, just
Yeah,
update him. And
done.
I think the Dr. Pritesh has also joined. Welcome, Dr. Pritesh.
Thank you, sir. Thank you for having me.
Yeah, hi, welcome. Dr. Manthan has also joined. Welcome, Dr. Manthan.
Hi, good evening. Good evening, everyone.
Hi. Okay. I think Dr. Manu just signed off. He was there.
Yeah, hello.
Dr. Manu, are you there?
Yeah. Hello. Is I'm audible?
Yeah, you're audible. I think your name has changed to Drishti somehow. I don't know. Or I'm seeing it like that.
No, that's I'm not able to log in using that my distro.
Okay. Okay.
So there is a. Okay.
So I think we can start the proceedings. So, hello everyone. Good evening, and I am Anurag Mishra. I'm professor of surgery at Maulana Medical College, and I work at. So I'm getting some. Just a second. Yeah. So I am also working in Medical Innovation Center at MAMC, and we are very happy and pleased that we are having the second edition of our webinar series, which is a monthly webinar series on AI for doctors. And I think that was a very palpable need to bridge this technical know-how. We were playing with AI tools, but I think to make it more efficient, I think we need to learn this skill in a much better way. And that is the idea behind having this series. And I'm thankful to the variety of panelists we have. And in the same series, we have two excellent and very experienced and learned panelists today. And I see Dr. Munisha has joined. I can't see her in the audience. Can anyone see Dr. Munisha in audience? Can you please upgrade her to the
Yes.
panelist?
I've sent a request to her to promote to the panel. She had to accept it.
Right. Okay.
Yeah.
And so I think to take the proceedings further, I'll request Dr. Manu to moderate this session. Or maybe we'll just take one more minute. Dr. Munisha is the Dean of Maulana Medical College. Ma'am has joined us. Welcome, ma'am.
Thank you.
Yeah. So, ma'am, we are just kind of were introducing the theme, and we would love if you can share something, or you want to listen through and then maybe.
Yes, I will rather listen through and then say the things.
Okay, perfect, ma'am. That will be awesome. So I'll invite Dr. Manu, who is coordinating this whole webinar series, to please moderate this session. Dr. Manu, over to you.
Yeah. Hello, everyone. Good evening. I'm Dr. Manu. So today's topic is about that healthcare data. So before starting any healthcare data, that any project, it may be AI project, that data is the most important things. So that quality representativeness and also that determines the success and failure of the AI. To guide us through this, we have a two excellent speaker, Dr. Manthan Mehta and also that Dr. Pratesh Sethi. So the first I would like to introduce that the first speaker, that is Dr. Manthan Mehta. He is a physician who works the intersection of healthcare technology and human behavior. He is a co-founder and chief medical officer of ISCA AI. That company is a mission to make that healthcare effortless through the automation and AI. And also, he is an advisor for various digital health startups, and also he conducts various AI workshops and for the clinicians, and mentor that aspiring that various healthcare tech founders. So today, I will invite first speaker, Dr. Mehta. So please start with your first session.
Thank you so much, Dr. Manu. Thank you so much, MAMC, TIH, and everyone for having me here. And it's really delightful to see that we are touching more than 100 participants, most of them medicos interested in understanding AI and healthcare data, which is very heartwarming to see this kind of shift. So I'm going to talk about healthcare data from a perspective that I think some of you who follow me on LinkedIn saw. I started my post today for this webinar stating that doctors know how to save lives, but unfortunately doctors don't know what to do with all the data that comes with all those lives. So we'll try and keep it simple, and please feel free to stop me at any time in case you need any questions, etc. Just share my screen. All right. I hope my screen is clearly visible and I'm audible. Can someone please confirm? All right. Thank you. Great. So we're going to talk today about, understanding healthcare data for AI. And the first question that comes is why this matters, right? Why are we having an entire webinar series on AI for doctors, and why is this session focused so much on healthcare data? So I like to begin with this caveat that a lot of people feel that AI is a magic wand and it can do wonders, or it can do whatever we wish it to do. And I remember my professor of statistics once told me that, if you torture numbers enough, they will confess to statistical significance the way you like it. And that holds true for a lot of things. And with AI also, it is only as good as the data we feed it. It is no magic. It's technology, it's science, a lot of data science in it. And we keep talking about the garbage in, garbage out principle with AI. You keep hearing it. And I think you'll keep hearing it forever till, we are at that stage where we have fed it the right data. So the idea of discussing this today is that healthcare AI is booming, right? But poor data quality is one of the biggest reasons that models are failing in real world settings. And I'll take you through some interesting cases around this and try and understand why it happens. Students, clinicians, and startups often don't know where to start when it comes to data, right? When we set out on a mission to various data sets and data points in terms of healthcare data, it was a Herculean task in terms of where to start, what to begin, and what to be careful about. India offers unique opportunities and, of course, challenges for healthcare data-led AI. And I'll share some personal stories as well around this. So the idea today is to equip you to think clearly about what types of healthcare data exist, where and how to get it, what are some risks and guardrails, which is my favorite topic to talk about, and how do we contribute ethically and effectively to this. So when we talk of the real world scenario, right, we have to understand where AI goes wrong. And the image here is more to talk about that we always aim at the moon, star, and and theoretically, a lot of things work, even when you do space missions and calculate everything to the T. But in the real world, it just gets complex. And healthcare, as I'm sure, to an audience of so many doctors, I don't need to say how complex it gets. So let's look at a very, very simple model. And this is a real study. I'm not naming the model or the company, but there was a cancer detection model, which tried to come and put its footholds in India. Very promising. It was trained on a lot of imaging data. And this worked, was tried to be done on oral cancers. And like you all know, India is one of the leading countries when it comes to oral cancer cases. And this screening could have really worked wonders. But it failed. It disastrously failed when we tried it in rural Indian clinics. And some of you, I'm sure, are guessing the whys, right? One is different imaging modalities that were used, lack of annotation consistency. The way annotations were done in the West did not probably be consistent, particularly in rural Indian settings. And the previous model entirely had skipped Indian cases, especially rural Indian kind of cases. And these seem very, very generic problems. Like, didn't they think of this before they came here? But no, unfortunately, a lot of us don't think before launching these ideas here, thinking that it should apply, extrapolation should work. However, local context in data is critical, and that was a lesson that this company learned the hard way. But you all are all wiser, and you all are learning it just from their mistakes. So, basics of what is healthcare data, right? You know all of this. Just a recap around it is clinical data, which is EMRs, lab reports, prescriptions, vitals, imaging data, discharge summaries, etc. Right? So, we while everything encompasses healthcare data, dividing it into certain buckets always helps us when we are trying to work or utilize this data and its data sets in AI modeling. Operational data like hospital logistics, billing, pharmacy, inventory. Behavioral data, app usage, adherence, device interactions. Social data like demographics, social determinants, survey responses. Genomic data in terms of sequencing, omics, biomarkers, or unstructured data. Doctor notes, radiology reports, and call center transcripts. So if I pose a question to the audience on what kind of data exists the most in healthcare and the most in India, I think you should just look at the top and the bottom of the list, right? We have a lot of clinical data, but a lot of it is unstructured. So when somebody asks me on what kind of healthcare AI have you worked on, and we say we work on healthcare data, and does it work encompass everything? Is the question we should be thinking. So most of them focus on very specific things. For example, Dr. Manu mentioned about my venture at ICSA prior to what I'm doing today. But so we were focusing more on behavioral data and merging it with clinical data and not focusing on any of the other parameters. Versus there are many others who focus on one given set of data. And the reason why you do it is, homogeneity of the data, catching that niche and understanding everything around that data. But the biggest need gap is in unstructured data. So what is this difference between structured and unstructured data? So to make it very simple, if you look at the examples of structured data, it is lab values, vitals, ICD codes, etc. The challenge here is that they're easy to analyze, but they're hard to standardize across systems. The way the systems operate in MAMC may be very different from the way it operates in AIMS. And, we may not be able to really standardize both those systems, right? Semi-structured. So somewhere between structured and unstructured are semi-structured data, like chat logs, survey forms, etc., which requires parsing, which is nothing but data cleaning. So it requires a lot of cleaning, because if you have a chat log, while we're talking about a lot of things, you need to really clean all of that information and bring that in place. And another challenge being context tagging, right? You need to really give it the right context in terms of chat. Sometimes when we joke with people, we add an emoji. If you're being sarcastic, we add another emoji to give that context that, okay, I'm not trying to hurt you, but this is a joke. And we as humans understand that, but for machines to really do it, you need to really clean that data and tag it with all the right context. Then come unstructured data. audio, call transcripts, free text notes, images, a lot of it, right? A lot of us use handwritten prescriptions today in the OPD as well, and all of that comes as notes and big files that you need to really digitize. And to extract real value out of it, you will need either natural language processing for text and audio based inputs. For imaging, you may need computer vision, etc. And like I told you in the previous slide, research from IBM told us that unstructured data makes up more than 80% of healthcare data. There was another study, by Microsoft, very interestingly, which said that from all the trillion kind of data points that we collect in healthcare, the real utilization has been only at 3%. So that's where we stand when it comes to healthcare data. So this is how the data lifecycle in healthcare AI works. First step, of course, is collection. This method of collection can be either through an app, through device, through hospital records or medical records. Then happens the storage of this data. Where do you store all this data? You store it on cloud, you store it on local servers, or you have electronic health record softwares which store the data and then transfers to cloud after that. Once you have done this, the most important step after this is labeling it or annotation of the data, because without the right labels, you will not be able to proceed to the next step. The next step is pre-processing and cleaning. So you're now cleaning all of that data set. So just as of yesterday, I was, monitoring a phase 4 study in oncology, and we got a lot of data which came in very, very weird forms. For example, diabetes was called diabetes mellitus somewhere, was called type 2 diabetes somewhere, right, as comorbidities. Surgical procedures done in oncology were again named very, very differently in all of that. And that requires that entire step of pre-processing and cleaning. So just imagine, when you have thousands of such data points, you will need to pre-process and clean it. Otherwise, the machine is going to see all of them as different points where it actually means the same thing. Then comes model training and validation, right? Now you need to train your model on all the data that you've acquired. Just training it is not enough. You will need to validate it. And after doing that, also, you cannot sit back and relax that, hey, my job is done. I've trained the model, I've validated it, everything works. Monitoring becomes very, very key. And so is retraining, right? You need to keep reinforcing. It's just like preparing for exams. You go and collect a book from the library, collect information, notes from your seniors, and all of that. Then you start remembering it. You start marking your notes. Then you start deciding, okay, these are important questions in the exam. How do I, now focus only on those? Then you start training yourself more and more on that. Then you probably give some mock exam to validate what you've done. And then you, of course, have to, retrain, because what you did in theory may, have to be trained again for Viva. So just to put it very simply, critical point here is that each stage needs ethical, technical, and very legal guardrails. All of these steps have to follow these three things without fail. So, the data needs may really vary, so if we see, we'll now explore what kind of data is needed depending on your objectives. So if you're doing a student research, your objective is different. If you're doing a clinical AI research, your objective is going to be different. For startups in the industry, the objective is very different. And if you're doing it for regulatory or FDA-based applications, again, it is very, very different. And what of it has that each of these kind of objectives needs, a different depth of data, different kind of documentation, and different ethical safeguards, to be expected. So the needs will vary, and we need to cater to each of those needs. I believe a large audience here are students, and for student research projects, I think a lot of things, the data sources can come from open data sets. I've just named a few, but I would urge you all to look up at Google's open health data sets that they have opened for the public, particularly for healthcare professionals who want to train and understand on this. We also have Kosh AI, which the government of India works on in terms of opening a large number of data sets for use, right? most of these data sources that you will get will be either simulated or synthetic data sets. And you can also get data sets from institutional projects if with prior ethics approval. Certain tips when you are using all of this is, one is you start with publicly available data, because you have to start somewhere, and that will avoid some ethics delays and permissions, etc., because these are open sources. Never use real patient data without approval, right? Also, there is a big trend which I see amongst a lot of medical professionals also, who love being tech savvy and AI savvy, is that they want to jump into machine learning or creating models, or working with their tech counterparts. But first focus should be on data cleaning, also then on exploratory data analysis before you actually jump into machine learning. And most important is to document your data sources and its limitations, because when you train any of these models or work on them, simulated or synthetic data sets, you need to explicitly mention that your models have been trained on this. Yeah, and people really are very critical when it comes to these aspects, in terms of what has trained your data. Because if we go back to the quote we started with, that AI is only as good as the data you feed it. So please mention those sources and limitations that every data point may have. Some examples, if Dr. Manu and the organizers agree, I'm willing to share this slide deck with the audience. You can use some of these data sets, and then there are many more that you will understand. Kaggle, I think, is a good place, again, to get a lot of data sets for healthcare portals. When we talk of clinical AI research, the data requirements in this case would generally be longitudinal patient records, and you would need labeled outcomes, right? And some clinician notes. The challenges here become the annotation costs and the inter-rater reliability. So, a lot of companies are working on this very aspect, where they are trying to minimize the inter-data variability and trying to reduce annotation costs and make that data more and more homogeneous. Biggest problem that we see is missing data and inconsistent formats. So this has been an issue with clinical research in general, because like we mentioned earlier, we don't have too much of standardization yet, and the formats being inconsistent. While we do it for research, sometimes we are dealing with smaller data sets and data cleaning, and some data operators are able to do it manually for us. But when we do it for AI, this inconsistency and missing data becomes a very big challenge. So the pitfalls here when we look at clinical data annotation is, label leakage, which means, for example, future outcomes in training data and various other parameters that happen there. There is inconsistent annotation that happens across centers, and domain drifts. What applies to an urban hospital may not apply to a rural PHC, and hence if a data is trained only, and when you try to do this, sometimes a common pitfall is also that we try to make the data so homogeneous that its extrapolation to other domains become more and more difficult. So just some best practice for people who work in this domain is to use double annotations, adjudicate your findings, and leave an audit trail. So it's very easy for you, not for auditors or any other committee, but for you as a healthcare researcher, to find your data trail in the right way. When we talk of startups and the industry, the goal here is a little different, right? We are here trying to build usable products, improve user outcomes, derive real world evidence, and all of that. In these cases, the data sources usually come from PSP programs, partner hospitals, content-based registries, etc. If I talk of the ICSA patient journey, where here we tried to model data, we used a data set from the US, which was a chronic care company, and they had data of over 65,000 patients across 8 years, which gave us some 60 million plus interactions and data points. And we put it through WhatsApp, EMR, and call centers. And in full transparency, we tried to replicate this model, and to see the entire thing, whether the model breaks or not. We tried to put it first on a rural setup in Bihar. and we went to a tier 2 town and did with a particular hospital in similar chronic care settings, only to realize that a large part of the data set that we've got from the US will not extrapolate here, and we had to regenerate a lot of data points from an Indian context and setting. So with that goal, you need to work. Here, the goal is to build a better product, and hence we worked on that difference. From trials and other data sets, how does real world data differ is what we figured. We figured that whatever trial data sets we used from the past were very clean. Transcripts were taken, they were all cleaned and perfect. In the real world, we saw very low. None of the data was clean. Strict protocols were there. Real world, it's variable, even in terms of collecting the data to getting the right data. Labels were predefined, right, in the data set that we were utilizing. But when we did it in the real world, we realized that there's often missing data and label because nothing's clean. The symptoms that the patient describes, or even the prescription of the doctor or the advice given by them is very variable, and it was not labeled in the right way. Utility, those were all used for regulatory submissions to the US FDA, and hence very regulatory. Here we wanted it for product personalization, and the entire thing worked very, very differently. So I'll just touch upon this aspect of regulatory grade data and what the US FDA needs. The regulatory grade AI will require a traceable data provenance. They require your annotator logs. I mean, I've used this term a lot of times in the presentation because these logs are required. Audit trail for model versions, and most important, they expect is clinician in loop verification. When we ask how doctors can contribute in AI, it's a lot to do with the clinician in loop, not just for verification for regulatory purposes. In my opinion, it should start right from the beginning for anybody who's trying to build a healthcare product. Some examples of what the FDA has approved, something in diabetic retinopathy, something in colon cancer. From an Indian regulatory context, CDSCO has limited AI specific regulations, but a lot of, from a data perspective, a lot is mandated through the DPDP Act in 2023, which talks about consent architecture, purpose limitation, etc. ABDM is trying to promote data exchange with the right consent to bring in interoperability, a challenge which we spoke about earlier. Some practical barriers to healthcare data in India is that paper records still dominant. I think studies say that only 4% of India has an EMR adoption. There is lack of interoperability that we discussed, which ABDM is trying to bridge. Very high variation in documentation styles. Even if it is a digital data, the documentation style variation is very high. There is the cultural sensitivity around privacy, I would say, is very low. We all come from Indian joint family settings, and we understand that privacy in Indian culture is not as seen culturally the way it is seen in the West, and that follows through even for data. A lot of us knowingly and unknowingly give away our data privacy by clicking a lot of things when we browse through the internet, and same thing happens, but people are very cautious in terms of healthcare data. So it's a little different, and poor digital literacy, of course, in some patient segments. Certain ethical issues, that consent a lot of times is not truly informed when we are talking of data. Data reuse happens without transparency that, I'm collecting this data for now, but it's going to be reused. Digital redlining, something in AI data sets become very important where you exclude poor data, or you exclude rural forms, you exclude whatever is incomplete, and commercial exploitation happens without patient benefit. So, when we talk of all the wonders that healthcare data can do for us, it's important to note each of these ethical issues as well. A bit on legal protections, we follow the DPDP Act for now. We don't have something very specific like the HIPAA or the GDPR in the US and EU. Role of students, right? How can you help? How can you be involved when it comes to healthcare AI and data collection? You can be helpful in terms of open data curation, right? You can use some low code annotation tools. I would urge you can look it up, label box, snorkel, etc. You can use and see what can be done. You can do some contextual AI testing to understand whether this model is valid for India or not. And you can learn a bit on documentation and train yourself in reproducibility. So, responsible AI practice would be to always use institutionally approved data, de-identify the data at source, never share raw patient data on any of emails or open things, maintain a change log of data and model experiments. Small difference between anonymization and de-identification of data is that when it is anonymized, it means there are no direct or indirect identifiers. It cannot be reversed. De-identified data, direct identifiers are removed, can possibly be reversed. Right? Best practice is to always anonymize before you share data externally, but keep your internal logs secure as well. So a bit on data sharing, do's and don'ts. Sign data use agreements, use encrypted drives, right? No-brainers there. Do not copy hospital data without any written permission. I'm sure Dean Madam will agree with that. Don't use WhatsApp screenshots in your machine learning projects. A lot of students actually do it. And do not publish any code with any embedded sample data, right? So to end it here, what you should take away from the entire thing, I think just 5 things: that AI is algorithm plus data plus context. India's health data challenges are unique, which also give you a lot of opportunities, right? With every challenge, there's an opportunity. Always work within guardrails, not outside them. You don't need a degree to contribute ethically. And please document everything because data is a story. And thank you. I'm open for any questions that you may have.
Yeah, thank you, Dr. Manthan. So it was a nice talk that you covered that every aspects about that how students should know about the data, how can they access that various free tool data. First they can focus on free tool data, then they go for that real data set, and also how can they gather the data. So that is a really, and also they need to focus on when they go for the new projects, they should have privacy, that things also they should know about that. Okay, if anyone have a questions, you can ask in the question and answer session. At the last, we can take that questions later also in orally. Okay, if you have any doubt, any questions, you can write it down, write it, then we will answer that. Okay. Yeah. Thank you once again. Okay. So we'll move to the next speaker. Then we will, at the end, we can answer so many, whatever the questions have our audience. Okay, next our speaker is Dr. Taupritesh Sethi. So he is a professor in the Department of Computational Biology and he is a founding head of the Center of Excellence in Healthcare at IIIT Delhi. He is a physician scientist. He works at the intersection of the computer science and healthcare. He is in IIIT Delhi, as well as he is institution in Ames, Stanford University, and also has done PhD from the Institute of Genomics and Interactive Biology. And he serves as a scientific advisory committee for ICMR, National Institute of Epidemiology, and ICMR, National Institute of Occupational Health. He is also a TEDx speaker. He has developed early warning system in the pediatric neonatal ICU and also for COVID-19. He has more than 50 publications. So I will welcome you, Dr. Sethi.
Thank you, Dr. Shetty. Thank you for having me here. Delighted to be in this August audience and speaking to students. I think very close to my heart. About 10 years ago, I was speaking in person at MAMC, and the idea was to communicate and enthuse the audience with the potential for AI. I think today I won't have to spend a lot of energy doing that. So let me just quickly share my screen and and Please let me know once it comes up. Are you able to see my screen, Dr. Shetty?
Yeah, yes, we can see.
Perfect, thank you.
So, just I want to remind you that we have a mixed audience, the 40 students and PGs and even that tech students be.
Wonderful, wonderful. No, I think I hope I'll be able to. I'll be able to leave. I leave the audience. Everybody should be able to get something out of it. So I'll basically focus on data and data science, and a little bit of our research on building health systems, preparedness with data and AI, of course. So data is the fuel. So the way I think about it is that in the modern day AI system, especially for healthcare. I think we in India are on the right path, but we also need the right car, or the right vehicle. And for the vehicle or the car, data is the fuel. And the engine of this vehicle is obviously by now we know is the foundation models that in AI we talk about, but that's not enough. We also need a gearbox gave a lot of good insights into different kinds of data. And as clinicians, we typically engage these different modalities of data. We see the patient as a whole. We don't just look at an X-ray and then make a decision. We also look at their history. We also look at the treatment that they're having and so on. So essentially, we need a kind of a gearbox which engages these different modalities of data to make decisions. As the previous speaker also said, that human needs to be in the loop, right? We need a brake system as well. So doctors in the loop, domain expertise in the loop is also key. And then essentially also having a navigation system, and which is, I mean, these days we're not there yet at all, but I think agentic systems where we'll have these different data types talk to each other, different models talk to each other to create the pathway for a patient to give a certain outcome. So I think that's where we see now. That's where we are headed in, at least in healthcare. But I'll begin at a very basic level. My talk is going to be structured at a very basic level, and then perhaps I'll mention what could the road to the future look like, but also some of the challenges in that. I would like to start with this news story that was published in 2020. The date is 25th of January 2020. And this is 7 days before the CDC alerted the world and 10 days before the WHO alerted the world that a pandemic is coming. There is this company called Blue Dot, which raised alerts that we may be entering into a pandemic scenario in the world. And Blue Dot is a company based in Canada. The founder is a pediatrician, Dr. Kamran Khan, who migrated into data science and completely changed the way epidemiology is done. And I think that's where I think the students in the audience, the PGs in the audience, can actually think about alternative career trajectories where you can think about data science as actually a viable career trajectory going forward. But how were they able to actually build these early warning systems was through novel ways of thinking about data and not just doing epidemiology in the traditional way. So what they did was they basically integrate a lot of streams of data which are non-traditional. And that's what my talk is actually going to be focused on. That in India, we complain a lot about data and the lack of data and the quality of data and all of that. But I think at the same time, we are actually sitting on gold mines of data, which if you are able to explore and exploit, you would have a lot of headway into building models. So they basically used data from flights and social media to actually raise alerts and thinking about non-traditional ways of doing epidemiology, as I said earlier. So it was still not called the coronavirus. We didn't even know that it was a coronavirus. We're still calling it a Wuhan virus. But they had actually done this before as well. So it's not just a fluke. It's not just a company that just gave some signals. They've done it for Ebola, published in the Lancet. They've done it for Zika and so on, and continue to do some good work along this line. So another example. This is a paper from 2023, Nature Medicine, a visual language foundation model for pathology image analysis using medical Twitter. Now, we may think that, oh, we don't have annotated data and we don't have a lot of data which is digitized, but smart ways of thinking about data. This team just went on Twitter, medical Twitter actually, and they curated medical Twitter to create a data set, which they called Open Path, of 200,000 pathology images paired with language descriptions. And I think that's the power of students coming together. If you actually think about this, there's something called crowdsourcing, right? But if India, we say that we don't have data, but we have a lot of people, right? So if we actually are able to bring together these two different things and actually crowd fund and crowdsource these data sets, our data sets will outnumber these data sets by a huge extent, I would say. So 200,000 images is not a small number, but I think we would achieve this number maybe in a few months, if not weeks, just looking at the kind of data patient loads we see at AIMS, MAMC, and so on. Right? So I think what I'm trying to say is that if we think in ways that are non-traditional, data sets can be created. And data sets can, and this foundation model actually is a great model. We've used this, we work with AIMS on a histopathology imaging initiative for neuroblastomas, neurotumors. And I think this model OpenClip is one of our foundation models that we actually develop with and go forward with. But this is the kind of thinking that the world is entering into, that we know that data is fuel. Can we create novel ways in about thinking about this? And this is actually, the previous speaker also talked about annotations, right? Annotations being expensive. So this model OpenClip actually is a way in which you pair images with text and try to match. For example, you can say retrieve from the database images which look like a certain, let's say, the frontal lobe and a certain kind of cancer, and it'll give you the images, right? Something that you can do with images on the internet, but wasn't possible for medical images so far, but is now possible. This is called contrastive learning, and that's currently one of these frontier areas of research. And this is how they basically built this Twitter-based pipeline, trained encoder decoder models on text and images, and were able to actually match text to images and so on, blah blah. Not going into the details, but that I think initiatives in India are possible like this, and be achieved in a short amount of time. Okay, so I'll spend next minutes or so basically talking about data. I've already spoken a little bit about non-traditional data types, right? But also mention how AI is consuming data to predict. But somebody attacks our or data, it's a liability, right? So about data that we currently have. So we're speaking about some of these things. Does anybody have a question? I think I heard some. If not, I'll just keep going. So what we do is basically on the left hand side is a real painting from the Kunst Museum in Basel, Switzerland, and basically in this painting that you identify objects. Right? And this is typically how healthcare data look like: messy, unstructured, there are multiple models you'll find that may be useful. And identify see tower, perhaps a propeller here, like maybe garbage in, garbage out. Unless you have domain experts in the mix, it's going to be very hard to sanitize the findings that AI throws at us. And a lot of that is actually about the left-hand side of the story, where how do we really interoperability architectures. Unfortunately, our medical courses train us in a lot of statistics as well. In addition to the clinical courses, but there's very little emphasis paid on interoperability, right? And that means how do we actually, if I'm typing something or if I'm storing something, right? How does a computer see that piece of information, right? If I say pneumonia, how does a computer see pneumonia? It obviously doesn't see pneumonia. It sees a code for pneumonia. How that code is built, right? Or what are the different systems? For example, SNOMED, CT, LOINC, ICD, and so on, which basically encode this piece of information. Unless we bring clinicians in the loop of interoperability, it's very hard to get to data sets which are clean. So I think that's a very well recognized thing. And also, interoperability is important to have shared information. Now, imagine if MAMC in the time of COVID-19 wants to exchange some information, let's say with AIMS, right? Or maybe bed information with AIMS or patient findings with AIMS. It's very difficult, right? So you need interoperability to be there, or even within department or within the hospital and between departments. And you may ask, why should somebody share data? There are studies which show that actually sharing of information leads to sharing of patients, and which is economically viable in the long run, even for private healthcare setups. It's like saying that why should Zomato and Swiggy have frameworks where you have these kind of sort of rewards provided by similar companies, right? So now it's very well understood that Zomato and Swiggy will share clients, and they exchange information all the time, and it's useful for both of them, right? So essentially, it's a win-win scenario. Okay, so I'll start with some of our own research on building these interoperability initiatives and building these data lakes in some of our initiatives. So one of the first one is what we do with AIMS over now 10 years now. It's called the Safe ICU initiative. We realize that there's a lot of data in the ICU settings, which is generated because ICUs are data-rich settings, right? So every time a patient gets plugged onto monitoring equipment, data generated, the heart rate, pulse rate, oxygen saturation, respiratory rate, etc. Tests are ordered, reports come back, treatments are written down, and so on. So it's a very data-intensive environment, but we don't store these data, right? Because we don't have the interoperable frameworks. So we realized that this gap is something that we should plug. So in 2015, we started this initiative by just building these HL7 based and open initiatives like the FIRE and SNOMED CT based initiatives to build software for the ICU, pediatric ICU teams, and which led to now more than 2 million patient hours of information at every second resolution for these patients. And we are going to make this data publicly available on AI Kosh, as well as on the AIMS web pages. The NDAs are being currently processed as we speak. It's being supported by ICMR and DPT. So hopefully this data should become publicly available, a large resource for students to play with. Currently, there's only one resource globally that exists such as this. It's called MIMIC. It was a collaboration between Harvard and MIT, and majorly adult ICU data sets. And as the previous speaker said, that when you try to build models and make it make them work in Indian settings, we failed drastically. So we need our own models, we need our own data sets. So why should these data sets be made publicly available? So for example, here we built models on our own data, which were then validated on the MIMIC initiative, but also the EICU initiative. And we were able to build models for shock prediction, and also for hypothermia prediction, sepsis prediction, so on. And some of our models are actually uh, validated in more than 200 ICU settings with more than 90% accuracy. Why we are able to do so? Because there are data sets which are harmonized from the US settings, made available, as I said, in the Philips and the MIMIC initiative, we need more of these from India. We'll change this, as I said, with the Indian data sets going forward from the Safe ICU initiative. So we show in our cohorts that it's important. So for example, if we have these kind of data sets and we are able to predict within the first 72 hours of patient admission, by just looking at their data sets like vitals and their reports, we can predict mortality at the end of stay, or I mean, mortality is a hard outcome, length of stay, and this was valid for both the MIMIC, Safe ICU, and EICU initiatives, just because we were able to have interoperable data sets, right? So data sets which could talk to each other. So that's why it's so important. I'll skip this. We are launching this as a dashboard at Ames. So I'll switch to public health settings. Again, why interoperability is important. ICMR has been building a network called IAMR-SN of more than 20 different sites across India, collecting data for antibiotic resistance in interoperable formats. So it's the framework that they use is called the GLASS, which is a WHO format for interoperable AMR reporting. So every microbiology lab basically reports AMST data, right? You send us isolate like blood, and they will see if there's the isolate has, you send a sample such as blood, and it would have isolates like E. coli or Klebsiella, whatever, and in that isolate, then cultured isolate, you test for antibiotics, and then you see the resistance patterns, right? So this network basically has collected data from more than 20 different tertiary care centers for more than 10 years now, and we were collaborating with ICMR, and we had data from 2017 to 2022. Since these were interoperable, we were able to actually build models with these data sets, which are data science models, which allowed us to, for example, make projections like 0.25% month-on-month increase in imipenem resistance in Klebsiella sepsis across the Indian settings, right? So that's where interoperability is such a big key factor in these kind of models. But our goal is not just to raise alerts or alarms. With such kind of data, for example, even with your microbiology labs, we show that without doing expensive genomics or plasmid transmission dynamics, we are able to get, just by using these AMST routine data, that what's the lead time for spillover of infection between hospital to community or community to hospital, just by doing some cool data science analysis, such as the causality, lead lag kind of analysis. We don't have the time to go into this today, but for example, here in Klebsiella sepsis, hospital to community, there's a lead time of about 4 months, and without doing genomics, right? Just from routine microbiology data sets. Similarly, we can see if I see a certain antibiotic resistance emerge, will a certain other antibiotic follow the next coming months, and so on. I'll skip this, but we showed that in this paper, which was published in the Lancet Regional Health last year, we showed that tackling this challenge is important because if we layer these data sets together, right? And since we're talking about data sets and also innovative ways to think about data sets, what we did here was basically we layered data sets from these tertiary care centers on the backdrop of the development of the state from which these hospitals were coming, right? So Niti Aayog's data, which basically talks about sustainable development goals, and ICMR's data, which are completely different data sets, were layered, right? And the development data was a canvas, and the ICMR's data was sort of the data point moving on that canvas, right? And we could see that we could make models which actually linked things like SDG 3 achievement and independent resistance are actually quite tightly linked to each other. States that are doing good on SDG 3 achievement are actually doing better on independent resistance as well. Now, this is a tug of war because we typically think that, oh, if there's more development, it might lead to more tertiary care hospitals, more antibiotic usage, more irrational antibiotic usage. It may lead to more antibiotic resistance. But also at the same time, more development is good to prevent infections, more hygiene, and so on, right? So at least our data from India shows that better development, more development is good for bringing down the AMR patterns, right? We show this, so in another paper which is currently under review, we show this for UTIs as well, where SDG and independent are again coupled. But that paper is available as a preprint. You can go and look at it online, and we show this in this paper as well. Actually, I'm running out of time, so I'll be very quick. But with these data sets which are interoperable, we build models which can be deployed as application in the hospitals to track how are we doing on antibiotic resistance. We call it the MR Orbit Scorecard. This was an award-winning innovation last year in one of these innovation challenges called the Vivli challenges. But we are also one of these Trinity Challenge winners, which is a global challenge from Trinity College London, and where we are rolling out some of these strategies, not just in hospitals but also in the community settings. And we are currently doing this with Bangalore, with Karnataka and Dharwad. So, and in that we are partnering with Tata 1MG, PATH, ICMR, of course, and then we are rolling out these applications to create these scorecards. I'll skip this. We launched a game last year, which was called Infection Escape. So you see some of this is, some of you, many of you would have played Temple Run, right? So it's like a game which is similar to Temple Run, but basically helps us collect data on the awareness of antimicrobial resistance from the community settings, right? So this is just a screenshot of how, for example, in Karnataka, we are rolling this out in Kannada language. Also, Hindi and English are available in the app in our AMR Sense project. I think I'll skip some of the modern AI representations, but once you have these different diverse sources of information, right? So things like data points that you have from a game, data points that you have from text, data points you have from signals like heart rate, pulse rate, ECGs, etc. Ultimately, the goal of all these is to all this input space is to basically learn a joint space, which is like the mind of the AI model, which is the feature space, right? And then it'll basically lead to some output, which could be like prediction of shock, prediction of sepsis, or whatever you would like to do, right? And I'll skip the teaching part of it, that how modern day AI systems work. Basically, they work by using probabilities and then essentially building sequences, right? But this is the concept that I was telling, that in modern day AI, every data point is a vector, right? And from your high school, you would remember that vectors can be added, vectors can be subtracted, multiplied, and so on, right? So if you can think that what this allows you to do is that basically in modern day AI, you can take a vector which would represent gender, and the same vector when added to man would take to woman, same vector and add it to uncle, can take to aunt, can take king to queen. And this was one of these key Google's, one of these papers from Google's, and this was a key insight that you could do algebra, right? You can subtract man from king and add woman, and the answer would be queen, because you can do vector algebra, just as we learned to do algebra in high school. Why this is important in medicine? Because you can actually, for example, add and subtract different symptoms, right? And different tests and values, and that will give you projections that will point to the right output space. Easier said, difficult to do, but this is the way the world is moving, and there's several foundation models which claim to do this for healthcare settings, right? I'm skipping all these, how do these models work, and what are the different architectures from Google and so on. This is all computer science papers that, for example, by how do they work by looking at frameworks such as attention. If you're interested, we can maybe chat offline. But at the heart of all these models is something called a transformer, right? So when we say chat GPT, the T in transformers, in chat GPT is transform, right? So it's the heart of all these modern day models where everything is a vector representation, and then basically you are using transformers, either the encoder side or the decoder side to build models. Skip this in the interest of time, but you would see that these transformer models are breaking data science, they are breaking data sets, everything, right? And they're growing bigger and bigger, right? And they're also being made publicly available, which means any one of you actually can run such a model in a Colab notebook just by downloading such a model, for example, from Hugging Face resources and so on. Okay, so I'll skip the metrics of assessment that you would do, but these models have biases. So one of the things that students from the medicine field can actually contribute a lot is to help understand, is the model biased, right? So is the model biased against some stratification, right? So for example, if the patient is a certain age, certain gender, certain socioeconomic criteria, does it give as good prediction as in other classes, right? Okay, I'll skip our own work from vector models and genomic sequences, but that's where basically we are headed in the interest of time. Language models in applied to public health. I'll just end by giving some sort of let's say what to be aware of and where AI can go terribly wrong, right? As medical students, we have a lot of contribution to be made in that space. So definitely we are in the hype cycle of AI. This is called the Gartner's hype cycle, right? And you can see different things in AI are in different phases of hype cycle. So the hype goes high, and then basically we realize, oh, it's a hype, and then it starts falling, and then people start pulling out, right? And that's what happened in the AI winters. But then people start seeing value, and then again there's a slow increase, right? So we see that for most of the things in AI, for example, AI in diagnostics, I think is somewhere here. We are still in that increasing hype phase, right? We have not yet crossed the boundary where we can safely say that we are beyond the hype. No, right? But for some things, for example, personal health records, electronic medical records, mental health apps, we are way beyond the hype, the fall cycle, and now we are actually seeing value getting generated out of it, right? So maybe you also want to position your own thoughts on where in the cycle you are in terms of creating data sets, which will help perhaps make it easier to go beyond this hype and to achieve this phase as soon as possible. So how do you do that, right? So first of all, I'll just give this example where more than 300 models were built during the COVID-19 times to detect COVID-19 from images, but zero of these models were actually used in practice. And this was a paper published in Nature Machine Intelligence. Why? Because most of these models did not provide the right data set information. So whenever you are actually publishing a paper or doing research, you need to actually provide all the metadata information about that paper, right? And that's where I think most of these AI papers really fail. They don't report what was the design. Many times they would not report the metrics, right? And they would not pass the quality and so on, right? And so, for example, things like how was the final model selected? What was the data pre-processing? What was the training approach? Most papers did not show that. So when you build models, please make sure that you are making the studies reproducible with data sets available, right? Many did not complete external validation on data sets, did not perform robustness, did not report demographics of their data partitions and so on, right? Again, this is an important thing. And the fact is that a lot of these models were actually a joke, right? So, I mean, many people actually tried, for example, giving an image of a cat, and and in the image of a cat, it actually would give 100% confidence that this is COVID-19, right? So essentially, we don't have mechanisms to track back from AI. It's garbage in, garbage out, unless you have the right data sets and the right data partitions to actually backtrack why this decision was given. Similarly, this was a famous paper from Stanford, dermatologist level classification of skin cancer with deep neural networks, published as a paper in Nature, letter in Nature. Huge amount of work with ontologies, with a lot of work, but then basically they found that it was biased against the dark skin populations, right? And this was reported, and they performed great in light skin, which is the curves here, but in dark skin, it failed miserably. So you as students actually can help understand biases in the models, annotate, and generate these data sets. I mean, the power of AI is not in building new architectures, but the power of AI is in creating these data sets.
Dr. Sethi, Dr. Sethi, if I can come in, I think we'll have to wrap up because we're going much ahead of the time.
This is my last slide. So yeah, so this is my last slide. So basically, biases have to be avoided, and that's where you can actually come in. So to summarize, data is key. Data comes in several forms. Everything is a vector. Context needs to be built into the models. Open data are key. Capacity building networks are needed because it can't happen in isolation. We need more data scientists who are trained at the interface. But collaboration is also key. So I'll stop here, but not before acknowledging my collaborators and the teams that have gone into it and the funding sources. So thank you so much. I'll be happy to answer questions later.
Yeah, thank you, Dr. Sethi, for that nice talk. And also, you totally explained about the interoperability of the data. That is a big challenge. So most of the questions was answered. There is a one question left. So how can we authenticate the data that has been in crowdsource before implementing them in studies? So during that time, I will ask the participants, we please fill out that post session that questionnaires. Okay, that after that we will get you will get a certificates.
So was that question directed to me? Can you please repeat the question again?
Most of the questions Dr. Manthan has answered. There is how can we authenticate the data that has been crowd-based, the crowd-based
source? So great question.
Before implementing them in studies.
No. So these data sets were actually annotated by clinicians. So that's where I think what I wanted to communicate was that a team of clinicians looking at medical Twitter, annotating them, and creating this large 2 lakh patient data set. So this was not crowd-sourced as in any common person. This was crowd-sourced by and annotated by clinicians. So obviously, still you would have to authenticate that data. That's exactly what we are doing in the data sets that, for example, we are working with clinicians, with our clinical partners in different hospitals. So essentially, you would always have to authenticate because there will be different settings. Maybe there was a different scanner, there was a different machine. It may not work at MAMC, it may not work at AIMS, and so on. So you always have to authenticate. But this paper that I mentioned about was actually dataset created by clinicians.
Okay. Thank you, Dr. Sethi. And also, I would like to invite our Dean, ma'am. Hello? Yes, ma'am.
Yes, Dr. Manu. I think
Final words from you, ma'am. Yeah.
I think both the talks were extremely informative. Whatever I could understand, I don't claim to, have digested the whole both of the lectures in completeness. But in very simple terms, I realized that yes, data can be a big liability for any of us if it is not technically, ethically, and correctly, expressed or put. And it can be of use only if it is, very judiciously used, and we represent everything as vectors, as Dr. Sethi pointed out. But in midst of everything, I would like to say that there should always be a human in the loop in the entire process, because as Dr. Sethi repeatedly mentioned, it's garbage in, garbage out. So to validate everything, a human interface is very, very important. Because this problem I have just faced as Anurag, and you must also be knowing that 15th Monday is the last day of thesis submission. So many of our, not many, most of our students have used Chat GTP, for writing their discussions, 80%. But when they come to us with those discussions, you can, very, obviously make out that they have not applied their mind or intellect in interpreting that data. So they have just, arbitrarily fed in the data to Chat GTP, and the discussion is, there. So that human, in the loop is something very important, I think. But both the talks were very informative. Yeah, thank you.
Yeah, exactly, ma'am. You are right. So they should not blindly use the AI tools. They should understand what they are using. Then only that will be. Yeah. Okay, thank you, ma'am. And also thank you, the speakers, Dr. Manthan Mehta and Dr. Sethi. And also I thank everyone, Dr. Anurag, Dr. Sabita ma'am, Dr. And our team, Priyansh. So, and also I thanks the participants. Please, I kindly fill this postage form. So thank you everyone.
Thank you.
Thank you.
everyone.
Thank you.
Thank you, ma'am, and thank you, Manu. And we'll be back next month with another edition of webinar. Bye bye.
Thank you, Ashima.
Thank you. Thank you.